Okay, good morning, everyone. Of course, my presentation is part of the work package number 6, Innovative Solutions for Sustainable Fruits and Vegetables Production to develop a decision support system in the framework of RUC-APS project, of course. And the WP leader of this work package is Nicola Calabrese. I'm Angelo Parente, and I'm a researcher at the Institute of Sciences of Food Production of the Italian National Research Council. In this presentation, I'm going to talk to you about examples of innovative substrates in horticulture.
So, course, Angelo, before you continue, Angelo, sorry, are you recording this session?
Yes. My coworker is recording this session.
Okay, thank you very much. Well, thank you, Angelo. Thank you. So, thank you.
Okay, in the slide, I reported my email, so you can contact me in the next days, next weeks, for further information about the topic of this presentation. Okay, I think that the first question coming in the listener mind might be, why do we need to use an artificial substrate? It's worth to remember that an artificial substrate is mainly used in greenhouse cultivation, even if I'm going to show you an example of use in open field as well. So in greenhouse cultivation, the main areas using artificial substrates are represented by cultivation in pots and containers, soil systems, and nursery production. In each of these areas, using an optimal substrate is essential to obtain high-quality plants and to guarantee high yield. In fact, a bad substrate choice can completely compromise growth and production of plants, as shown in these pictures. On the contrary, a right choice of a substrate in terms of physicochemical and biological characteristics like pH, EC, porosity, water and air capacity, absence of phytotoxic substances, this last mainly in case of organic substrates like compost, give us the chance to grow high quality plants characterized by high yield and high quality of edible vegetable products. In this presentation, I don't go deep into the physicochemical and biological characteristics of growing media, but I'm going to present you a case study of an alternative and innovative substrate and show some application of it in experimental trials. Of course, there are lots of artificial substrates or growing media that can be used in vegetable and nursery field. But one of the most extensively used, other than rock wool or perlite, these last are an organic component derived from rocks. One of the most extensively used is peat. Peat presents optimal physicochemical and agronomic characteristics, but peat poses at least two huge concerns connected with its use. The main one is that peat is not a renewable material, so there are huge environmental concerns related to the exploitation of peat moss. The second one is that it's quite expensive for farmers. For example, in Italy, it is totally imported from abroad. And just to give you an idea, in this slide, I reported the quantities and costs of peat used in some European countries. And as you can see, Italy is one of the main peat users. Okay, based on these premises, it is fundamental to develop new materials to use as growing media in pot, soil culture, and nursery as alternatives to peat. This is also according to the UE recommendation. In fact, the UE has strongly encouraged the use of peat-free growing media, even better if they are based on the reuse of organic wastes with or without composting them. And now I will show you a case study in which a material, the Posidonia residues, considered a waste until a few years ago, could be used as a resource to make up substrates to use in soil culture and nurseries with an example of application in open field too. What is Posidonia oceanica? Posidonia oceanica is a marine fennel game endemic of the Mediterranean Sea that grows all along the coast, forming extensive meadows from nearly the water surface to depths up to 40 meters. Among the marine plants, Posidonia is the most abundant seagrass species in the Mediterranean basin, covering approximately 40,000 square kilometers of the seabed. The plant produces between 3 and 10 tons dry matter per hectare of meadow per year. And the amount of litter reaching the coastline depends, of course, besides marine currents and winds, on the width of the meadow. We can roughly estimate that about 25% of Posidonia residues reaching the coastline. This means that a moderately wide belt of seagrass of about 1 kilometer may deliver 125 kilograms of dry seagrass litter per meter of coastline each year. The extent, of course, of the beaching process is particularly intense, mostly in fall, when the highest loss of material coincides with increasing wave action and transport. On the beaches, we can find deposits of leaves on the left side of this slide, but also fibers. Fibers are residues of rhizomes and decomposed leaves. And finally, balls of fibrous material called egagropili accumulate usually along wide coastal areas from a few centimeters in the water to several meters indoors, inshores, sorry. In this slide, I give you an idea about the quantities of beached Posidonia residues. For example, in Mola di Bari, South Italy, for a length coastline of 800 meters, we measured 8,800 cubic meters of residues. In Torrecane, a touristic place near Brindisi, we measured about 2,600 cubic meters of Posidonia residues for 600 meters of coastline. In some cases, the management of Posidonia residues looks like a fight against giants. Just to give you a visual idea about the intensity of the phenomenon, of the beaching phenomenon, here I'll show you what happened on this short beach, about 60 meters long. At this moment, the residues have been just removed from the beach. We are during the summer season. But this is the situation on the same beach a few months later during the autumn season. There are about 700 cubic meters of Posidonia residues. And the same phenomenon happens in other places of the Apulian region. Here we are in Manfredonia near Foggia in 2008, see to the beach. And this is the situation just 3 years later. The residues had occupied a large part of the beach. And similar events happen in other places of Italian coastline. The presence of Posidonia biomasses along the coast could represent a problem, a complex problem for the coastal municipalities when the accumulation interferes with, of course, economic and recreational human activities. Here we have some typical cases. The presence of high amounts of residues close to urban centers may represent hardship because of the odors that develop from the accumulation, or even a danger due to the possibility of fires with consequent problem of public health and safety. Or again, the residues can interfere with the touristic use of beaches. In fact, the uncontrolled decomposition of Posidonia organic residues can cause the release of hydrogen sulfide and the development of beach flies, reducing the potential utilization of coast and beaches for recreational and touristic purposes. In all these cases, the coastal municipalities are forced to remove seagrass residues. And according to Italian law, the Posidonia residues collected on the beach as alternative to landfill could be composted even if at a maximum amount of 20% on weight basis. Okay, but as we know, life is not simple. So there are two main obstacles to the large use of this waste biomass as raw material for composting. The first one is the high presence of sand mixed to residues after removing them from beaches. In fact, the Posidonia residues can accumulate until to 153 kilograms of sand per cubic meter of residues. The second one is the high salinity. The high salt content could be very high because, of course, of their marine origin. Through some studies conducted in the framework of the European Life Project, whose acronym is PRIME, we overcame these two obstacles, increasing the attitude of Posidonia residues for compost production. And for example, thanks to a prototype machine developed in the framework of the project, more than 90% of sand could be separated from residues, washing them using marine water. On the other hand, the salt content could be reduced, storing Posidonia residues near to the beach for a time long enough to ensure that the rainwater washes away the salt. In this trial, we simulated rainfall and measured the quantity of salts washed off. And the results demonstrate that it is possible to reduce the EC of runoff in about 2 months. Here I reported some chemical characteristics of raw material, both leaves and fibers. And as you can see, the residues are characterized by high EC, an IEC value due to the high content of salt, mainly sodium, calcium, and chlorine, but also leaves show higher total nitrogen content and lower carbon content than fibers, with a good value of carbon total nitrogen ratio for composting. And in fact, in this slide shows some chemical characteristic of based compost obtained, based Posidonia compost obtained after 90 days of composting. And as you can see, the properties of the compost are very good and in line with the limits of Italian regulation. Okay, in the coming slides, I will present you some application of the Posidonia compost as an alternative and innovative substrate to substitute totally or partially some common substrates and primary peat. The first application regards the nursery plant production. And in this trial, lettuce seeds of 2 cultivars were grown on a polystyrene plug trays filled with 5 growing substrates obtained by mixing a peat-based commercial substrate with increasing percentage of Posidonia-based compost. And the results demonstrated that increasing the compost percentage in the mixture modifies physical characteristics, decreasing water capacity, but increasing air capacity and also porosity. This is important to know because farmer can manage a low water capacity of the material, the growing media, for example, increasing irrigation frequency, but cannot manage a low air capacity of the substrate that could generate anoxia problems at root level. Lettuce seedlings in the trial showed an enhanced overall growth with increasing the presence of Posidonia-based compost in the growing media. And keep in mind that in this trial, no minor mineral fertilizers were added. And these are some pictures about this trial. In this experimental trial, tomato plants were grown on in soilless system, and we had tomato plants that, as I always said, were grown on three substrates compared with the grafting combination, and the results showed that plants cultivated on Posidonia compost alone or in mixture with perlite show the higher leaf area, yield, and number of fruits per plant than control on perlite used alone. In another trial, lettuce plants were grown on five substrates represented by peat, mixture of peat and Posidonia compost and compost alone. The percentage are expressed on volume basis. And the lettuce yield in terms of fresh weight was higher when plants were cultivated in compost and mixtures respect to peat represented by represented the control. Lettuce plants show the same results in terms of leaf area. Another application in soil cultivation was about green bean. In this case, 7 substrates were tested, peat used as control, 3 kinds of compost obtained. The first one mixing Posidonia residues with municipal organic waste. The second one mixing Posidonia residues and sewage sludge. And the third one mixing Posidonia and green waste, and of course mixtures of them with peat. The results are summarized in this slide in terms of green bean yield, and as we can see, there were no statistical differences among the substrates, except in case of compost used alone, probably because of the high quality of the high salinity level in the media and the intrinsic sensibility to salt of green bean plants. And as I promised, in this case, this is an open experimental trial in which we used Posidonia-based compost as soil improver or mulching material compared with mineral fertilization for the cultivation of lettuce. The graphs show that plants fertilized with the highest amount of Posidonia compost, in particular ACVP20, were not differentiated in terms of fresh weight from those fertilized with mineral fertilizer for both lettuce cultivars. Okay, I've quite finished my presentation. We are working now on new perspectives to utilize Posidonia residues focused on organic biofortification. We tried adding non-composted Posidonia residues, both the leaves and fibers, to peat, with the aim to increase some human health mineral elements in microgreens. Microgreens are small vegetables consumed at the 3 or 4 true leaf stage. And the results showed that a reduction of nitrates and chromium content in the plants and a slight increasing of zinc. But, and this is very interesting, the plants showed a clear increase of iodine and boron content, increasing Posidonia leaves and fibers quantities in the substrate. And furthermore, there was also a clear increase of iron and manganese, increasing the quantity of fibers in the substrates. Okay, just to summarize, the use of Posidonia could reduce the use of peat and chemical fertilizers, and presence of compost in the growing media resulted in a general enhancement of growth and yield of plants, and increased the availability of nutrients in the growing media. The optimal results by our experimental trials, we obtained the optimal results in terms of substrate properties at a dose of between 20 to 50%. And as a new perspective, Posidonia raw material might improve the nutritional profile in vegetables. Okay, I finished my presentation. Thank you for your attention.